What?
Risk assessment.
Fire, burn, electric shock. Okay. Right. Okay, folks. This is what we call a Maltese cross. Another name for it is that it's a vacuum tube. Alternatively, you could call it a particle accelerator. It's all the same thing. What you have here is an element that gets very hot, just like inside the kind of apparatus that produces X-rays. And what happens is these electrons are accelerated forwards by a difference in potential between this point here and this point here. The difference in potential, this potential difference, is supplied by this extra high tension voltage supply. Now, high tension means high voltage. This is extra high voltage. This is producing a voltage way above what the Van de Graaff generator can produce, so reasonably dangerous. What happens is the electrons in here, because they're travelling through a vacuum, they do not ionise the air because there is no air. They travel through the container and are almost invisible as they travel through this section here until they land on the screen at the very back of the container. Now, this here is a phosphorescent screen. It's a chemical that glows when electrons hit it. It's the same chemical that is on old-fashioned TV sets on the screen in the front. Now, what I'm going to demonstrate when I fire electrons through here is that they will travel straight along and be absorbed by the metal. And so you should see a shadow of the metal cross on the screen at the back. After that, I want to demonstrate the effect of a magnetic field on those particles with this magnet that is presently stuck to the trolley. This is the major magnet. It's the strongest magnet we have, and it's so strong that getting the bar off the front of it is very difficult. Now, I will have to be careful with this because with all the metalwork in me, this has got the power to remove it. So I have to just be careful where I point this thing. It's an extremely strong magnet. You can have a go, have a play with it in a little while. Okay, I shall turn it on. It will take a second to warm up, assuming that it's on there. Aha, there we go. Right, okay. So you can see the hot element at one end. I'll take the camera at this point because it needs to see quite closely. At one end here, you've got a hot element, just like in a light bulb, but in the vacuum, what's happening is it's firing electrons at this screen here. And you can see the shape of the cross, which is simply just a shadow being produced there. Now, the major magnet itself, Ed, if you could just take the storing bar off the major magnet.
I think I'll try. Not that, Eddie.
Right, thank you very much. Now, I do not want to break the GoPro with the magnet.
Oh, the effects are right.
Okay, so if I approach with the magnet, even here, right, you can see it's having an effect on the magnetic field. As closer I get, I can push the electrons really far away. I can push them here. It's even possible to make them do a hula hoop and make the cross appear upside down. Further back I put the magnet, the more obvious the effect, I can twist the magnet, change the shape of the magnetic field by changing the orientation of the magnet that we place close to it. I can do it with a smaller magnet. Right, a smaller magnet has a more subtle effect, but it still works fairly well. If I change the orientation of the magnet, I can make it go one side and then the other side, one side then the other side. Well, this is what happens in the TV set, an old-fashioned one, where changing the orientation of the magnetic field by having an alternating current going through an electromagnet basically enables the actual beam of electrons to stream from one side of the screen to the other really quickly, and this enables them to build up the picture. Okay, ta-da! Right, so come and have a play. Go on. If you stick the magnet to yourself, it's your own fault. Oh.